we've seen evidence of them on the moon and on Mars.
Okay.
And in those environments, at least personally, there are some really exciting reasons to study lava tubes.
Giant Leap with Taylor Wilson.
Hey, welcome to Giant Leap. I'm Taylor Wilson.
And I'm Joey Lovato. Taylor, today we're talking about lava tubes.
Lava tubes, one of my favorite geological structures.
My only experience with lava tubes is going to Lava Beds National Monument in Northern California with you, and we were like a quarter of a mile into this pitch black lava tube, and my headlamp died.
That's why you always have to bring it back up, Joey.
And I was just
First rule of caving.
I was holding on to you, oh my God, where are we? So yeah, tell me about lava tubes.
Well, I'm not joking when I say one of my favorite geological features, both here on Earth and also extraterrestrial lava tubes.
People don't know this about you, but your catchphrase is that you love the underground.
I do love the underground. And lava tubes in particular are fascinating. They basically form when a volcano erupts, typically with a volcano that has very low viscosity lava that erupts onto the surface out of vents. And as it drains out, the channel or the tunnel that it leaves behind is what we call a lava tube.
Okay.
And these can be small. They can be relatively small tubes that are only maybe a few feet across or even smaller. They can be very big. I mean, we have visited lava tubes that are, 50, 60 feet wide.
Yeah, huge.
And
highly recommend Lava Beds National Monument.
Very cool place. And I've done a lot of scientific work around lava tubes, specifically mapping them, coming up with techniques to map them using LiDAR and even techniques like muon tomography, where we use cosmic rays to determine the structure of these lava tubes.
Sure. Why are we mapping lava? Why do we care?
Well, I mean, there's interesting reasons to do it here on Earth. It tells us about volcanology and mineralogy and all of these things. But for me, the real interest is the astrogeological implication, right? The fact that we are pretty sure that these lava tubes form on bodies other than Earth. We think we've seen evidence of them on the moon and on Mars.
Okay.
And in those environments, at least personally, there are some really exciting reasons to study lava tubes. On the moon, for example, the lava tubes potentially are the harbingers of ice. There could be deposits of water ice inside these
and they're
kind of
long
shielded
snaking
systems.
Tubes.
Yep.
So water gets in there, freezes. And
yeah, there could be deposits of water ice inside the lava tubes on the moon, which would be really useful as a resource to make, of course, drinking water and oxygen for habitats.
Like
and
a moon base.
Yeah, but also, propellant to refuel ships that are going, outside of the confines of the Earth-Moon system.
We could use water as a propellant?
Yeah, we split it into hydrogen and oxygen, and that's a propellant. Or
like a hydrogen engine?
Yeah. So you can take hydrogen, oxygen. That was the fuel for many of the largest rockets that we built. But now the new architecture is methalox, especially that SpaceX and Blue Origin are pursuing. Methalox is, of course, methane and oxygen.
Of course.
You take oxygen from the water, you take hydrogen from the water, mix that with a little bit of carbon from maybe dry ice, and you can make methane. So water on the moon is really important, not only for a habitat there, but as a gas station for, doing deeper exploration of our solar system. But on Mars, where we also think there are lava tubes associated with some of the volcanic systems we see, like the largest mountain in the solar system, Olympus Mons, we think we've seen evidence of these so-called skylights, which are essentially collapsed sections of lava tubes that are kind of the entrance potentially to some of these systems.
I did some great photography in Lava Beds National Monument with those skylights, actually, where you're in a pitch black tube, we, again, go a quarter mile into it, and then all of a sudden there's a light coming
collapse and an entrance into these tubes.
Yeah.
So on Mars, similar thing. There could be interesting deposits of dry ice or water ice in these tubes. There could be interesting mineralogy. But there are also other interesting things. For example, they could be a great habitat. On Mars, we really have to worry about radiation. On the moon, too, once you're outside of the protective magnetic shield of Earth, you're at the mercy of the solar wind and
Yeah.
galactic cosmic rays.
Well, I read today, I think it's like, is it 1.5 million tons is ejected from the sun every day as radiation?
Yeah, so there's
Yeah.
a lot of matter in the form of the solar wind being ejected off the surface of the sun, and that's radiation that's very harmful to the human body.
We'll have to talk about how the magnetic field of Earth protects us in another episode, because I don't understand how that works at
Yeah, we
all.
can definitely talk about it. But in this case, on Mars, we've got to figure out a way to combat that radiation. And there's different things we've thought about, but we really haven't solved that problem yet. One of the problems, or one of the solutions to that problem, is potentially using these lava tubes as existing structures. So we put our habitat down in one of these tubes. The regolith, the Martian rock overhead protects us from that, that bath of cosmic radiation.
Would it do a good job, similar to the way that we would wear a lead vest
Yeah.
when getting your teeth x-rayed?
Yeah, I mean, the idea behind radiation shielding is you just need matter. You need mass that
Okay.
interacts with the radiation and attenuates it. So if you have a lot of rock, that acts in the same way as a lead shield or a water shield or something
Sure.
like that. So that's potentially one good reason to study lava tubes.
Okay.
But on Mars, there's yet another kind of even potentially more exciting possibility, and that's that there is either fossilized or extant life in these lava tubes, that they might have the perfect conditions for life to
Mm.
form outside of the bath of cosmic rays and UV radiation that the surface has. You could think about these tubes or these cave systems as having almost independent ecosystems that are much different in their composition, their atmosphere, their temperature than the surface.
The Martian mole people.
Yeah. This is all, of course, very speculative,
Sure.
but you can imagine, because you've been in these tubes, how different they are from the surface. And that might be the perfect place to go looking for life on Mars if it still exists, or, if it once existed. So this research that I've done, that you've participated in a couple of the expeditions, involves coming up with the kind of robotic tools or, human-based tools that will allow us to determine where lava tubes are, map them, study the overburden. Those are all things we've done here using what we call planetary analogs, or places like Lava Beds National Monument, where these systems that exist on the moon and Mars exist here on Earth. So we can take things like LIDAR or muon tomography and demonstrate them here on Earth, and then send them up there and let them do the cool science for us.
Yeah, I know that those robotic dogs from MIT.
You've seen the ones I've been walking around.
Yeah, they do it up in Oregon. There's some lava beds up there, or lava tubes up there, and they'll send the dogs in, and they're learning to. It's kind of like watching them learn to walk, and in total darkness.
Yeah, the quadruped robots are a lot of fun, and every time I take one, or my graduate students take one for a walk up at the university, it always draws a crowd because everyone wants to see the robotic pet. But those are the
murdered
same
dog.
Yeah, the murder dogs. But those are the same kind of robotic systems that we have, really been thinking about deploying on the moon and Mars. And on Mars, even though the atmosphere is just a tiny fraction of what it is here on Earth, we're starting to develop things like, you probably saw this recently, the first demonstration of a flying robot on Mars. Those are the kind of technologies that can be brought to bear in these systems to do exploration and to, basically give human astronauts these, ability to more effectively explore these crazy systems like lava tubes.
Yeah. Well, look, will you be living in a Martian lava tube anytime soon?
Probably not. I would go, but I don't know that I would want to set up shop and live there for an extended period.
You can send some video messages back for me. I'll be happy. I'll be hanging out in the lava tubes up in Northern California.
Sounds good.
It's one small step for man, one giant leap for mankind.